Satu sungai di seluruh negara dikategorikan sebagai tercemar.
Pencemaran disebabkan bahan sisa buangan kilang.
Pencemaran Sungai Kim turut menjejaskan kehidupan sungai.
Bahan sisa tidak digunakan ke dalam sistem pembentungan.
We are a research team from School of Civil Engineering UiTM. The highlighted project entitled of ECO-Sorb for Textile Dyes Industry Wastewater Treatment. The heavy usage of dyes and other chemical agents have given a significant impact on environment and public health, which needed to be controlled in compliance to Environmental Quality Act 1974. Due to the significant amount of water used in various wet processing procedures, the textile sector was ranked as the third largest source of water consumption in 2020. The main objective is to determine the absorption of ECO-Sorb in real textile dyes industry wastewater. Absorption is one of the most common techniques. Activated carbon has proved to be effective and popular adsorbent but expensive. In Malaysia, there is limited studies using the ECO-Sorb such as papaya peels and kenaf waste in absorption of dyes in textile wastewater. Thus, an approach with the utilizations of the ECO-Sorb as additive to activated carbon were applied in this study. Approximately 20 liters of wastewater sample has been collected from textile industry. The business uses dyeing and finishing agents on daily basis for clothing decorative. The clean raw papaya peels were spread out on a tray to be dried in an oven at 100 degrees Celsius for 24 hours. Afterwards, the dried papaya peels was placed in a muffle furnace for 1 hour at 300 degrees Celsius to thermally activate it and transform into activated carbon. The green treated peels into a fine powder of the particle size of 1 mm for use as an adsorbent. The same method applied for preparing kenaf powder. Then, absorption studies were conducted to determine color, BOD level, and TSS in the wastewater sample. Before and after the treatment data were collected. Parameter of color, BOD, and TSS were successfully removed in the range of 75 to 80% by the combinations of activated carbon and the ECO-Sorb. The removal efficiency shows enhancement compared to individual adsorbent. This study will improve awareness on sources of textile wastewater pollution to the public and enhance knowledge on utilizing natural adsorbent known as the ECO-Sorb to the textile companies and DOE Malaysia. The papaya peels and kenaf waste is the unwanted part, which leads to the cost effectiveness in production of adsorbent. Minimizing waste generation also promotes environmental sustainability as well as sustainable ECO-Sorb for green adsorbent. The technology readiness level for this research is at TRL5. The TRL5 is achieved after the ECO-Sorb has been tested to the real textile wastewater samples. Collaboration with one of the local company where estimation the profit margin is still at our preliminary discussion stage. In order to increase the profit margin, we need to lower the product manufacturing costs such as collecting papaya peels and kenaf waste on bulk quantity. Here are the previous innovation awards received related to natural adsorbent. These are the publications by our team, and it is our aim to conduct for more research on natural adsorbent. Thus, we welcome you to collaborate with us to explore more significant outcomes to minimize the dependency on chemical adsorbent for wastewater treatment.